In this video, we can learn about a type of grammar which is called as context-free grammar. And earlier classes, we have learned about a type of grammar called as regular grammar, in which um, there were two forms like right linear grammar and left linear grammar. And those it will be those right linear grammar will be like it will be of the form to the right, that is a right hand side of the production will be having a single non-terminal to the right, and the left linear grammar will be like the production will be having a single non-terminal towards the left. That was the difference, and we have learned how the grammar is being used to derive the string. Similar is a concept that we are doing it in this context-free grammar, or otherwise you can give it as a CFG. So there is some restrictions that is imposed in this type of grammar, like here the tuples, it will be taking the form as V, T, P and S. It's the same as that of the regular grammar. Then V will be taking the set of non-terminals, T will be taking the set of terminals, S is the start symbol, and P, there is a difference here. You can see that it will be taking the form as A gives X. So this X will be either it will belong to the set of variables, or X can be a set of variables or terminals. Okay, it can take any form, either the variable or terminal. In regular grammar, what we have learned, to the right side, right hand side of the production, it will be starting with a string of terminals followed with a single non-terminal. So some restriction was there, isn't it? Similar in left linear grammar will be like a single non-terminal followed with any number of terminals. Okay, so such case is not applied on this context-free grammar. In context-free grammar, what is the condition? It will be taking the form as A gives X, and X can be any symbol that belongs to variables and terminals. So here a notation, that is star, is used, which means that an epsilon also can come to the right hand side. So you can see an example over here, that is for the grammar, if set of productions it is given in this form, S gives ASA, S gives BSB and S gives epsilon, you need to derive some string from the grammar. So this grammar, it can be considered to be as, grammar means this set of productions, it can be considered to be as a context-free grammar. Why? Because the right hand side, there is no restriction on the right hand side, and the non-terminal is coming to inside the that is towards the middle left hand side, and right, only restriction that is imposed in context-free grammar is left hand side of the production. It should be a non-terminal. Okay, left hand side of the production will be a non-terminal. Right hand side, it can be either epsilon, terminal or a non-terminal symbol. Okay, so from this, if we are asked to derive any string, means you can start with the start symbol. Here the only symbol that is found in the grammar is V is S. Okay, so we can start with S. So S is having some set of productions. From those set of productions, you can choose any one. So epsilon, so language will be having epsilon, empty string will be accepted by the language. Other string that can be accepted will be like, if you are taking ASA as the first production, and so you have to make use of the derived symbol ASA, and if in place of this S, if you are substituting, means it will be resulting in AA. So AA will be another one string that can be accepted. Similarly, if you take instead of this ASA, if you take S derives BSB, and in place of this S, if you substitute epsilon, means you will be getting as the string BB. So BB will be the another set string, and again substituting in different way. S gives BSB, and in place of this S, If you substitute ASA, what it will result into? B A S A B. Then if you put epsilon means what happens? You will be getting it as B A A B. Okay, so next string will be like B A A B. Likewise, you will be getting A B B A. That also you will be getting. Like that it goes on. So what is a common thing you can observe from this language? One is it will be accepting some even number strings. Followed with that, you can see that the string that is read from the left as well as from the right, it is seen, isn't it? Okay, which means if A, that is, this is A, if it is read from left it is A, and if it is read from right also it is A. Similar is the other case. This string also it gives the same B A A B. From the right, if you read means B A A B, A B B A. So what is the language you can generate from this grammar? You can say that W W reverse. Okay, W W reverse. So here you can define the language for this grammar as L of G is equal to W W reverse. So what is this W can be? W can be any element that is taken from the here terminals is A and B, isn't it? From the grammar you can understand that the terminals is A and B. So W can be any element that belongs to the set A and B, and epsilon is also it is being included, so you can take it as star. Okay, or you can write it like W W raised to R, W element T star. That is the T is considered to be as A and B. Okay, this is a way you will be able to write the language for the given grammar.